Hey guys, welcome to another system design mock interview. I'm excited about this one because we have the man from one of our favorite channels. It is Jordan Has No Life, and it's Jordan himself. How are you doing, Jordan?
Doing well, Tom. Thanks for having me on. So just to give a quick introduction about myself, like Tom mentioned, I run a YouTube channel focused on systems design interviews. And in addition to that, I also work as a software engineer. I was previously working at Google, and now I work at a high frequency trading company. So hopefully I have a decent idea of what's going on when it comes to this particular design. Anyways, I'll let it get back to him.
Yeah, great to have you on, Jordan. And yeah, it is a good channel. I know some of our subscribers actually requested you to come on here. If you haven't seen Jordan's channel, then do go check it out. All right, should we get straight into the interview?
Let's do it.
All right. Yeah, so Jordan has seen the question ahead of this. I wanted to try and kind of guarantee that we had a high quality answer that was as useful as possible for you guys. Jordan, the question I want to ask you today is, how would you design a stock trading app such as Robinhood?
All right. So yeah, thanks for letting me get into it. Let's see if I can type at all. Okay, that seems to work. So I guess, like you mentioned, we're designing a stock trading app. I'm going to use Robinhood since that's kind of the one that I know about the most. And so, I guess I'm going to try and lay out ideally the requirements of something like this. So the ones that I can think of are, of course, things like sending orders and, of course, keeping track of positions that a certain, client or customer might actually have. And also, of course, this is the one I want to focus on. So I'm going to put 2 asterisks here showing the actual correct price of stock or options. The reason for that being that I think when it comes to actually sending orders and maintaining a customer's like actual holdings, that's kind of trivial. You can do that pretty simply with a couple databases. Maybe you'll have to shard them a little bit if you really do have a ton of users. But for the most part, all the exchanges have an API. You're basically just forwarding their orders there. I think in reality, that gets a little bit more complex with payment for order flow and things like that, but we're not going to touch upon that too much ideally. So I guess my question for you, Tom, then would be, what are the type of capacity estimates we're looking at? Basically, how many users and how many stocks per user were you thinking?
Yeah, sure. Let's say 100 million users and around 100 stocks per user.
100 million and 100 per user. Okay, so I guess that gives me a couple of ideas here in the sense that, we do have 100 million users. So obviously we're talking not just 100 million users, but since we have 100 million stocks per user, we're looking at now, let's see, what comes after a million? I want to say a billion, oh my gosh, and then 10 billion after that because it's 100. So we now have 10 billion positions to basically keep track of. That's a lot of data to obviously worry about when multiplying the two of those. So yeah, a lot of positions. But I guess from here, I am going to, again, talk about my main concerns. Because like I mentioned, the part of this problem that I'm really hoping to focus on, if that's all right with you, Tom, is actually showing the correct price of the stock or the option, because I think that is kind of the real complexity here. So my main concerns are I want each client device to have a minimal load, because if each client device is connected to too many of our servers at one time, we could be draining the battery, we could be using too much data, and that would, be a problem. And then also it would be great if, we weren't connecting too many systems to the exchange, limiting our systems with the exchange connectivity. The reason being that you have to pay for that. And if we're Robinhood, we don't want to pay for too much of it. We don't want to be collecting too much data if we can avoid doing it and just keeping it within our system. So yeah, do you have any questions about just like a general design or anything?
Jordan works at a high frequency trading company, so obviously he has a really strong knowledge of how these kind of exchanges work. You would not be expected to know all these things. Instead, you'd need to ask the interviewer the right questions in order to understand how the system will need to work. I like that Jordan has already clarified the area of the problem that he hopes to focus on and explained some of the issues that he knows are going to come up over the scope of his design. Perhaps he could have come up with some of the capacity estimates himself, but it's okay that he asked the interviewer instead. Let's get into it. What's the general breakdown of the system that you want to go with?
Sure. Okay. So I've kind of thought about having kind of three main pieces for the system, and I guess I'm gonna write them down, but then I'll probably introduce them in a reverse order. So the first is some like user layer, and these are going to be servers that talk to our phones/computers. And then I'm also going to have basically an exchange layer. I can't spell, sorry. And I think these are going to be the servers that are getting exchange data. And like I mentioned, a really nice thing about kind of splitting these into their own layers is that we can scale them independently, which is good because we want to keep the exchange layer as small as possible. And we want to keep the user layer, perhaps as big as many client devices there are, to make sure that each client device is just touching one piece of the user layer. But I'll get into that in a bit. And then we've also got this routing layer. So the first thing that I am going to try and cover, at least in this video, is the exchange layer. And so for background, for whoever's watching this, because I think it's kind of important for something like Robinhood, is that most exchanges are not publishing just like, Apple is $80. What they're publishing is that Apple is, it's got one offer. So someone wants to buy it for $79. Someone wants to buy it for $78.5. Someone wants to buy it for $78. And then also on the other side of that, someone wants to sell it for $81. Someone wants to sell it for $81.3. And someone wants to sell it for, $81.6. So the exchange is never actually giving you a price that, is going directly to the customer. And what we see in Robinhood, which is kind of nice, it simplifies things for us, is one unified price. It's, basically this guy right here. And so as a result of that, what we need to basically do is, take the above. Hopefully you can see me highlighting stuff, and we need to convert it. And another kind of piece of that, which makes this hard, is what I just showed above is just one exchange. But in reality, there are a bunch of exchanges that are publishing the same different data. I think maybe this is less so the case for stocks. I actually can't remember, but for options exchanges, you might have like 78.7 and 78.3 and 78.1 and 81.6. And so basically what this is known as is called like the order book. And, the point is there's all this data throughout all these different exchanges, and we have to aggregate it somehow in order to provide just one price to our user. And that's what we would call the NBBO. And the NBBO is basically like what I'm going to say is the best bid, which is like, the best thing on the left side here, the best price that people are willing to buy for, no one else is willing to sell for, and then also the best offer. And I think in my mind, what I'd like to do is probably return to users the best bid plus best offer divided by 2. Do you think that seems generally reasonable?
Yeah, I think that's okay.
Okay, sure. So yeah, there are many different ways we could show this. We could do like a weighted average or something, but for now, I'm going to be focusing on just, providing a really easy valuation, which is just the best bid plus the best offer divided by 2, the average of the 2 in the order book. And so the issue now is that we're getting all of this feed data per exchange. And yeah, there are a lot of exchanges. So do you have any issues with how I'm handling this so far?
How are you going to deal with that? There's many exchanges when you're calculating the base price in your publishing layer. What's your plan for that?
So I guess the issue is, we have a lot of tickers. And when I say a ticker, I mean like symbols, like Apple or Google or Meta, and those are all the stock names. And we've also got a lot of data. And so we probably need some amount of sharding. But in my head, like, you need to make sure that all of the data from an individual ticker, regardless of exchange, is going to the same node. So personally, I would like to kind of shard the exchange layer by ticker symbol. And then, within one node, we'll do some processing. And ideally, what that processing is going to lead us to is getting our NBBO and taking the average of it so that we can give that back to our customers. Okay, so kind of what I was thinking from there, and let me know if you're okay with me going down this path, is it's not like a trivial task to actually get all of the data from these exchanges and like quickly republish it. So would you mind if I did like a little brief deep dive into the algorithm I was hoping to use in order to do that?
Yeah, please do.
Okay, so yeah, I mean, let me know if you think I'm going in the right direction, but kind of tentatively, my plan was to kind of have something like this. So we know each exchange is publishing data, and on a node, we need to know best bid and best ask at all times. And when a new best bid or best ask comes in from an exchange, it means that we need to basically invalidate the old one. And so what I was thinking is actually kind of maintaining like a doubly linked. So basically, on one given node, let's say just for Apple, I would do the following. I would say like exchange 1 is saying the best bid is $80. Exchange 2 is saying the best bid is $81. And exchange 3 is saying the best bid is $82. So that means that, the national best bid is $82 because that's how much someone is like willing to buy the stock for at the most price. And so my thinking from there was to basically, we want to be able to get that highest number as quickly as possible. And how I would want to organize these things is in a linked list, right? So shoot, I can't draw. It would be great if I had my iPad. Alas, I don't. So we kind of make a linked list. But the nice thing about this is that if we ever need to quickly compute the highest value, we'll make sure that our linked list stays sorted so that 82 is always at the top. However, for our linked list to stay sorted, we actually need to be pretty smart about how we organize things. So I think what I would like to do is do a doubly, can't spell, linked list with a hash map. And the nice thing about this hash map is that, if I say, oh, shoot, a new piece of data from exchange 2 is coming in. Let's say someone bids 83 on exchange 2. I could see that, the node for 81 is here because it's a doubly linked list. I could quickly remove 81 in constant time. So this is O of 1 removes. And then what I could do from there is I could, how do I scroll down more is the question. I figured it out. Awesome. Okay. What I could do from there after I've done that is I could then do an O of log n insert of my new node. And in this case, we would say, okay, we'll do 83. Why don't we get rid of this guy, binary search the remaining list, and then put 83 where it belongs. So now we've got 83 leads to 82, leads to 80, and we know our national best bid is 83 amongst all of our exchanges, which is great. And then we could do the same exact thing for the offers, but obviously, we want to see the lowest offer, not the highest offer. And then we could just quickly compute the average. Okay, cool.
Jordan is a very good communicator and is giving a textbook performance of how to communicate in system design interviews. He talks through his thought process with me very clearly, and he checks in at regular intervals to make sure I'm on board. He's also demonstrating strong technical skills. His knowledge of the exchange has allowed him to already get into complex considerations, such as aggregating the large amount of data the exchange puts out via a stateful consumer. These may have some fault tolerance issues down the line, so I'm curious to see how he approaches that.
That sound okay?
Yeah. So once the base price has been calculated, how are you then going to get it to the user?
Sure. Okay. So yeah, that's completely fair question, and definitely something that's a bit complex about Robinhood in particular. I think my kind of general thinking was, and I mentioned this earlier with my concerns, is we want to limit the number of connections per client. The reason being that, we could have every single one of our publishers. Let's say a client has Apple, Google, Meta. The issue is these are all different nodes, right? We're sharding by these. And so if a client has 100 stocks, that would mean they would have 100 different connections to publisher nodes, which is problematic for multiple reasons. It's problematic both on the client end because, they would have to directly communicate with those publisher nodes. And that would be really bad because you're maintaining a bunch of active server connections, whether that's either long polling or WebSockets or server sent events. And, that would either drain the device battery or it would potentially just, use a ton of network data. And also it would be bad for the publisher nodes because they're doing a decent amount of low latency calculations. It would be really great if we could kind of decouple all of that logic. So that's kind of where I was hoping my user layer would come in. So,
okay.
Yeah,
how
I guess let me know if you want to ask anything there.
Yeah, sorry. So yeah, how would you want them connected then?
Sure. So I guess I kind of alluded to this a second ago that we could be talking about, either long polling, right? Because we have, let's say, let me bring out the drawing, right? We've got our phone. Can I draw here? Yes, I can. Oh, can I draw in there? Maybe not. Phone. Great looking phone. Nice job, Jordan. So we've got our phone. And then in addition to that, we've got kind of our user layer. And I'll see if I can draw in here. It would be awesome, but I don't know that I can. So user layer. And so the question is, how do we want these two connected? My personal opinion, I think, because really we have three options, right? We can, the user layer is constantly going to be publishing values. And so that makes us decide between basically, where is my cursor right now? It's making us decide between WebSockets, which is a real-time protocol. It's making us decide between server sent events. And it's also, we have the choice to use long polling, where we basically open an HTTP request on the user layer, and then we maintain that for the whole session. And yeah, that's an option as well. Personally, I think I lean towards WebSockets, the reason being that these are two directional, and they also reconnect automatically. And you don't have to send request headers every single time, which is nice. And the reason I care about it being two directional is that our phone is going to be, phone is sending ticker requests to user layer, and the user layer in turn is going to be responding with basically, the prices of the stock or the option. And I think that's, pretty important just in the sense that, being able to make sure that connection is as fast as possible is going to ensure that we're getting as much data as possible and maintaining a low latency on our phone. And also just by keeping one connection between a user device, ideally, and the user layer of our server, I think that would be really, really useful to us. And then ideally, what I would want to do is, it's important, yet again, that we actually go ahead and shard our user layer. Because we have 100 million users, and that's a lot of devices. So in the ideal case scenario for sharding, what we would have is, we're horizontally scaling out. We have many different user layer servers, but in the ideal case, all of the users, or rather one user layer server, would keep a ton of, basically all of the common stocks between the users connected to them. So for example, if I had user one and user two, and they were connected to the same, layer server A, ideally user one stocks intersect user two stocks would be very high, would be large, because we ideally want to be fetching the same stock prices on the same user layer servers. In practice, though, I think that's just kind of hard to implement. And so for that reason, I think I'm just going to go ahead and propose a pretty simple round robin load balancing. So I'm still thinking about the kind of eventual design that I'm going to draw up here, and I will draw that out in completion, probably once I explain my thinking for the original piece. But yeah, ideally, I'm going to have a load balancer between the phone and the user layer. And that is probably just going to do some sort of round robin load balancing to make sure that a certain user layer server isn't getting overloaded by too many clients. Perhaps we could do that round robin in kind of like a weighted way where we consider how many different tickers that user layer server is already fetching, because it's possible that we have like power users who get a ton of tickers that they're requesting. But for the most part, I think this approach should generally work. Let me know if you have any questions about the sharding on the user layer server.
Yeah, interesting. I wanted to ask, what if one of these user servers went down? Like, how can you make sure this piece of the system is fault tolerant?
Sure. That's a fair question. So let's see. Let's write that out. And I will drag down a little bit. So, okay, we're talking about fault tolerance now, which is definitely a tough piece here because we want our system to be redundant in the face of any hardware issues or networking issues. I think it's hopefully pretty clear on a phone when their user layer stops sending updates. What we could do is have our WebSocket connection occasionally send heartbeats. And if our phone stops receiving them, then it's going to want to go ahead and just establish a new connection. And I think that's pretty simple for the most part. It can go through the load balancer. It is definitely true that if a user layer server with a lot of users goes down, that we could, in theory, have a thundering herd if we were to load balance poorly, where all of our kind of phones try and reconnect to a different user layer server and it overloads it. But I mean, that's kind of the point of using round robin load balancing, is that shouldn't happen. And so I think that just by making sure to use heartbeats, and if we really wanted to, we could even have like a zookeeper layer, which keeps track of the status of each user layer server. And that would help us to confirm that the user layer server is like actually down and it's not like an issue with the phone or something. But yeah, I think using heartbeats ideally should give us a pretty good sense of, kind of making sure that all the devices are getting the updates they need.
Okay, Jordan, could you explain to me how the user layer actually connects to the publishing layer?
Sure. So, like I mentioned, I wanted to talk about three pieces right here, and I've spoken about two of them right now, and then I'll draw it all out at the end. We've got our user layer, got our exchange layer, and the third piece is this routing layer right here. And so that is what I will now talk about. And so my thinking for the routing layer was, in theory, you have, let's say we've got X user servers, and we've got Y publisher servers or exchange servers, let's call them that. And what we know is that every single user server is probably connecting, or at least user server probably wants like at least 100 tickers, right? Because we know it's connected to at least one user. It's probably got many users in reality. We could be looking at thousands of tickers. May want thousands of tickers or ticker data pieces. And, that's going to be problematic, I think, especially potentially for the publisher server, if nothing else. I mean, the user server, it may be problematic too, but, that's what we have the sharding for. I think for the publishing server, though, the issue is, let's say 1,000 user, or not even 1,000, we have 100 million users. Let's say out of our 100 million users, every single one of them owns Apple, or maybe 10% of them owns Apple. We could potentially have 10 million devices or 10 million user servers or something asking for Apple. And if that happens, that could bog down our publisher, our Apple publisher. And so I would prefer that not happen, and ideally, continue to make it so that all of our different layers of our service can scale independently. And so what I would like to do in this type of case is add kind of like an intermediary routing or communication or whatever you want to call it layer. And so I was thinking about how I would like to do this. And I think a lot of people might end up just going with like a message broker here. I think something like Kafka does make sense, specifically because it's a log-based message broker. So all of the pieces of data that we publish would be persistent on disk, which might be nice for future kind of logging or diagnosis or metrics or anything like that. And also it would be nice just because then you only have to publish to one place, and many different consumers can get the message. But truthfully, the more I thought about it, I actually think that maybe a better solution would be to use something like a Redis cache. And so again, we can kind of scale these caches independently and use a load balancer and a zookeeper cluster to make sure of which cache is maintaining kind of the data for which tickers. But all this Redis cache is going to hold is actually going to be the option valuation or the most recent one. And so what it'll do is, publisher Tesla says, hey, the price for Tesla is now $450 after listening to the exchange. So exchange data comes in. Sorry, can't spell. Goes to the publisher who publishes $450, who goes to the routing communication layer, which again is nice because we can kind of scale, replicate, and do anything we need independently there. And so that's going to be the routing communication layer for Tesla, which is now going to update its value. Maybe it was 445 before, and now it's updated to 450. And then yet again, what you could do is use something like a server sent event or even a long poll, and that's going to go to our user servers, which then finally end up going to our client device. Let me know if you think that's okay. And then hopefully we can almost get to the full-on drawing of the design.
Okay, yeah. I did have another question I wanted to ask about what can we do if a publisher goes down?
For sure. That's really fair. And that's probably the other big piece of fault tolerance, is making sure that our intermediary routing communication layer and our actual publishing layer are also fault tolerant. For the routing communication layer, I think it's just a matter of using replication. Our publishers it's no big deal if each publisher is publishing to like 3 places instead of 1. It's a big deal if our publisher is publishing to 1,000 places instead of 1. So I think using replication 3x or something like that, totally fine. But as for the publishing layer, the kind of interesting thing is, again, my solution is going to be replication. However, kind of the interesting thing to note is that our publishers are stateful. So it's very important that every single kind of publisher, or rather the backup for a given publisher, is also receiving the same messages that our, kind of primary publisher is, because otherwise it's going to be the case that, what we would see is one publisher goes down and then the other one is going to have to take a little bit to warm up and get data from the exchanges before it can actually start publishing out stock and option valuations. So I think what that means to me is that personally, I think we should use something called state machine replication here, where rather than doing our typical form of replication where, like one publisher would send all of its state to the next, what I think we could actually do is have our backup publishers basically listening to the exchange, and ideally by listening to the exchange, getting the same type of information locally that the primary publisher would have. And then, for example, if our communication layer receives no update / heartbeat from our publishing layer / exchange layer, then, we go to Zookeeper, we say, oh, shoot, do we think this thing is down? If it is down, then we switch to our backup. That seem okay?
Yeah.
Okay,
Yeah,
cool. So
that makes sense. Jordan's almost 30 minutes into the interview and he hasn't yet started drawing. We normally recommend that you want to be drawing your diagram after 20 minutes or earlier. Jordan has taken another approach. He's first talking through the various considerations in good detail. And as an interviewer, I encourage this by asking him lots of questions. That means he now has a great foundation on which to draw his diagram. But another interviewer might have wanted to see some design mapping earlier. Yeah, please go ahead.
I was hoping to, we've kind of done all this background now. And I think what I'm hoping to kind of do from here is draw this out all in one aggregated diagram to really tie it all together. And then, if you have any questions from there, feel free to ask me more. But yeah, hopefully this really ties things together now that we've kind of done a lot of abstract talking. So I've got what I'll consider to be my client device over here, aka a phone, very simple. And, that phone is going to be showing things like Apple is currently $81. Google is currently $200 and Meta is 21. Okay, so we've got our phone right here. Seems simple enough. How do we make sure that these prices are actually getting to it? Well, like I mentioned, the first kind of aspect of it is that we want to establish some sort of WebSocket connection. So I'm not going to use a direct arrow here because these are two directional. So the first thing is that, well, I guess it would have to effectively request to get a WebSocket in the first place. And so what we would do is request some load balancer, I think. And I mentioned I wanted to do this in a round robin way so that our user layer isn't handling too much, but we've got our load balancer. And then ideally, what this is going to do is, maintain a connection with just one user server, where from then on, we can go ahead and perform more requests. So just give me a moment to think this through. But here would be an example of like user server 1. But, we're horizontally scaling this out. So we might have user server X over here that we're not connected to in this particular case. So for this guy, this is going to be a WebSocket connection where one of the types of things that you might do is say like, give me the price of Apple. And then in response, down the WebSocket chain, you would say Apple is, I don't know, $80. So yeah, that would be kind of the example of the user layer. And ideally, we could all scale this out independently. Now, in addition to that, we've kind of started building out our user layer. My next goal, ideally, is going to be to build out our communication layer. So again, I mentioned these were like a bunch of different Redis instances. Imagine that we have replicas and partitions right here, but I'm going to just kind of write this out, kind of freehand communication layer. And so, yeah, again, this is Redis. I think it doesn't have to be Redis, but the reason I like that in particular is it just keeps things relatively fast. All writes and reads are coming in and out of memory. It's effectively a cache, sharded by ticker, or some combination of tickers, sharded by ticker, and maintains connections for us. Cool. And then so that is effectively going to be publishing out to our user servers. Let me grab another arrow right here. And the nice thing about this is kind of managing all of our network connections. So managing overhead of networking, ideally. Perhaps this is a little bit over-engineered, but I'm going to go with it for now. And then the last thing that we've got, of course, is going to be our publishers, which are listening to the exchange, keeping data in memory. And so this is going to be like Tesla primary. And then we've also got Tesla secondary. And then we've got our Apple primary, and we've got our Apple secondary. And these guys, like I mentioned, are all just listening to UDP feed, which is coming from many, many different exchanges. Blah, 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 over here. And UDP feed, or rather, I think I should mark this as exchange 1. Because, for example, for options, from what I understand, there are, I think, 16 or 17 different exchanges that you have to be aware of. Exchange 2. Exchange 2. And then also exchange 3. And then all of these guys are in turn going to be publishing to just about every single one of our kind of exchange layer right here. And so it's important to recognize that, we're able to kind of aggregate these results into not only just an NBBO, but then one price that we can send to the rest of our application. So let's see over there. Hopefully you're starting to get the point at this point, but everyone is receiving all of the data. Okay. And then, from there, in turn, we've got we need some sort of coordination service like a zookeeper, which is going to, keep track of all of our partitions. It's going to be connected to everything, has a sense of what tickers are located where. And then, of course, we've got just our primaries at the moment publishing over here to our communication layer. And then the last piece of this, because even though I called it trivial, I should still probably write it down, is actually going to be, an orders/position service. So for this one in particular, I think there probably would still be a load balancer in between them. And ideally, what we would want to do with this load balancer is use something like consistent hashing. The reason being that, if someone is constantly trying to request what stocks or positions they're holding, it's probably not changed. And so it'd be great if we could actually, cache that on our orders and position service. Like, for example, if, this guy was split into 3 different servers, it would be great if for my particular user, I was always going to this server right here, because then the result of my query would already be cached. But in the background, I would imagine that for your orders and position service, there's basically 2 endpoints, one of which is taking your order to the exchange to get a position. And then, upon receiving a successful response to that, is probably going to go ahead and write to some sort of database. Let's see if I can draw that out. I personally think MySQL is fine here. I just, there aren't that many interactions with this. People on like a Robinhood app are not trading that frequently that I think your database is going to be your bottleneck. I think it's more significant to figure out the challenge of providing base prices. And I think something like, just shard by user ID and then have a positions table, which, for every single given user has a row like user ID and stock ID and, maybe some metadata like the price they bought it at or something. But truthfully, it's, that's kind of semantics from there. So yeah, this is kind of the design I'm going to stick with and perhaps double down upon. Let me know if you have any questions about it.
Okay, yeah, interesting. I think it looks like a good design to me. We're coming to the end of the interview, so we're going to have to wrap it up. But before we do, is there anything you'd like to just take a minute to look at it? Is there anything you'd like to refine or add to the design?
Yeah, for sure. I considering we don't have too much time left, I'm not really sure how much I can refine at this point, but I definitely think, if there are one area I'd like to think about a little bit more, it would probably be this communication layer right here. I'm pretty confident that Redis is a decently good technology to use here, just because we really only care about the most recent data point. We don't need a full queue. If for some reason, a consumer of the data is delayed, it's not important to get old data. Though I do just wonder if, what the best way to kind of scale this thing out is, ensure fault tolerance, kind of make sure that we're horizontally scaling out each layer separately, independently, in a good way that minimizes the amount of resources that we're using, keeps our costs down. So, nothing specific to necessarily change about this part, but I would probably just want to think it through a little bit more to ultimately make sure that I'm making the system as flexible as possible. But yeah, I think that's about it.
Okay, well, let's then end the interview there then. I was happy with Jordan's design and decided to wrap up the interview, but another interviewer might have spent a few more minutes with Jordan to dive a bit deeper into certain aspects. Perhaps I could have grilled them a bit more on the fault tolerance of the system, because even though his approach there seemed to be generally good, it might have been interesting to look at it in a bit more detail. In any case, Jordan made a smart choice in breaking his system into 3 different layers to scale independently, while also considering the load that it would have on client devices. Overall, a really strong design and a very impressive interview from Jordan. Jordan,
Sure.
Great job.
Sounds great.
Thanks for doing that. How was it? Did you have fun?
Of course. Always a great time making systems. So no claims, no issues there.
Great. Well, thanks for coming on, and hope we can have you back on here one day, because I really enjoyed it, and I think everyone will get a lot out of that. So thanks a lot.
Yeah, absolutely. And, if you're a viewer watching this, happen to enjoy the interview and want to check out some more, feel free to go look at my channel. I've got plenty on there. And like I mentioned, I have no life, so there's going to be a lot more. See you guys.
All right. Cheers, Jordan. Hello. Really hope you found that useful. If you did, you can like and subscribe. And why not come visit us at igotanoffer.com. There you can find more videos, useful frameworks and question guides, all completely free. And you can also book expert feedback one-to-one with our coaches from Google, Meta, Amazon, etc. Thank you, and good luck with your interview.